Modern corporate perimeters rarely fail because an attacker broke advanced cryptography. They fail because someone unplugged a server and forgot to tell the routing table. This chart shows the current state of major enterprise DNS records. 21% of them point to non-resolving content. They route traffic to dead addresses. Engineering teams optimize for speed and cost. When a project concludes, developers delete the cloud resource to save money on the monthly billing cycle. They assume this deletion eliminates the associated risk. That deletion leaves the canonical name record sitting untouched in the company's master DNS zone file. This orphaned routing rule is a dangling DNS record. This operational misalignment creates a persistent opening. It establishes a specific infrastructure flaw known as the empty lot exploit. This diagram illustrates the relationship between identity and routing. The DNS record is the permanent identity. It acts as a highway sign. The cloud server is the ephemeral routing destination. It functions as a rented building. Deleting the cloud resource without updating the DNS file is the physical equivalent of demolishing the rented building. The highway signs remain intact. They point directly to an empty lot. The corporate DNS directory continues routing global internet traffic to this address. The address is now a publicly leasable space on a third-party cloud provider. Threat actors deploy automated scanners across the internet. These tools hunt specifically for these abandoned routing rules and the resulting 404 HTTP errors. An attacker leases that exact empty lot from the cloud provider. They build a replica of your headquarters. Customers follow your official highway signs straight into an attacker's trap. This split-screen diagram highlights the organizational root cause of dangling DNS. The decentralization of cloud infrastructure separates operational jurisdiction from access rights. DevOps teams are incentivized by deployment speed. They are rewarded for ruthlessly cutting monthly infrastructure costs. A developer spins up an AWS S3 bucket for a temporary marketing campaign. 6 months later, the campaign ends. The developer deletes the S3 bucket to save $50 a month on the billing cycle. The network administrator controls the master DNS file. That administrator lacks visibility into agile project lifecycles. The cloud billing account registers the server deletion immediately. The master DNS zone file remains completely ignorant of the change. This gap in state synchronization creates a dangerous latency. The internal organizational silos ensure that while a resource is gone, the route remains available for anyone to discover. This flowchart tracks canonical name routing logic. The corporate subdomain points directly to a specific third-party address. Deleting the cloud resource releases that unique subidentifier back into the public pool. Execution is trivial. An attacker registers a new account and claims the exact abandoned identifier. Active corporate subdomains sit behind strict layers of security logic. Abandoned subdomains exist entirely outside that protective envelope. Firewalls monitor live traffic. Abandoned subdomains are silent blind spots. The attacker now hijacked a trusted SSL-certified corporate subdomain, turning the company's own DNS architecture against it. Attackers exploit this trusted connection to securely host credential harvesting phishing pages. Customers implicitly trust the official corporate URL. This diagram tracks a session authentication cookie generated at the parent domain. Organizations frequently scope cookies to the broad parent domain, failing to restrict them. The web browser automatically sends this sensitive cookie directly to the attacker-controlled subdomain. This requires zero user interaction. Subdomain takeover carries secondary impacts. Attackers bypass content security policies that blindly trust traffic originating from official company endpoints. This weaponized trust allows attackers to bypass traditional perimeter defenses simply by squatting on a trusted corporate URL. This exploit extends to email routing. The dangling MX record presents an identical mechanical failure. MX records direct email traffic for specific subdomains to third-party mail services. Decommissioning an email service without removing the MX record creates a direct opening. Attackers spin up a matching service and intercept incoming mail. This interception allows threat actors to capture password reset links. They also pass certificate authority validation checks to issue fraudulent TLS certificates. Leaving any DNS record type dangling transforms an administrative oversight into a critical multi-vector supply chain vulnerability. Security analysts deploy defensive strategies to preempt these attacks. They systematically close the visibility gap. This conceptual radar maps global network endpoints using continuous datasets. Platforms automate the cross-referencing of internal DNS zone files against live HTTP responses, flagging abandoned endpoints immediately. Analysts hunt for specific cloud service fingerprints, identifying AWS or Heroku errors. Operators validate this risk through a manual audit plan. They query the public DNS zone file. They issue an HTTP GET request to each endpoint. Operators filter the output for 404 status codes. They cross-reference the resulting list against active cloud billing accounts. Proactively discovering these service fingerprints allows teams to strip dangling records before automated threat actor scanners can exploit them. This infographic details the systemic fix. Organizations must establish a rigorous decommissioning checklist that enforces state synchronization. First, operators redirect the DNS record to a safe internal maintenance page. They refrain from deleting the cloud resource outright. Second, operators wait for DNS propagation across global servers. This delay is bound by the time-to-live duration. Finally, operators decommission the physical cloud resource. They execute this step only after the routing table safely clears. True infrastructure security requires the rigorous removal of obsolete state. Operators must decouple identity from routing. They must never leave an empty lot pointing back to the enterprise.